Hello, guys. I hope you are doing well. Here we are extending our examples of differentiating using the chain rule, where we start differentiating exponential functions. So the one that we have is the exponential function, y equals e to the power of 7x to the 5 minus 2x plus 1. Before I start, let me show you the page, just to remind you to please subscribe if you haven't already done so. Now let's get back to it. So first of all, note that if y equals e to the x, then dy dx is also equal to e to the x. That's going to be useful to us in a moment. So using our chain rule, we want to let u equal the inner function, which in this case is the exponent or the index. So we have 7x to the power of 5 minus 2x plus 1. I don't always get my words out the way I want them to be got out. And that was a perfect example of that. So we have y equals e to the power of u. Okay, then we have the du dx is equal to, or 7 times 5 is 35, so that's 35x to the power of 4 minus 2. And then, of course, the 1 differentiates to 0. And dy du, well, we've got e to the power of u, or remember, e to the power of something will differentiate to e to the power of something. So dy du will be e to the power of u. Okay, and then using the rule, of course, we have dy dx is equal to dy du multiplied by du dx. dy du was equal to e to the u, and du dx was equal to 35 35 x to the power of 4 minus 2. Okay, and then we can rewrite this like this: 35x to the power of 4 minus 2. It just looks nicer this way. And multiplied by e to the power of u. Okay, and u in particular was 7x squared minus 2x plus 1. So that is 35x to the power of 4 minus 2 multiplied by e to the power of 7x to the power of 5 minus 2x plus 1. Let's look at one more example. That's, by the way, the final answer. Let's look at another example. So let me just write down the rule again. So boom, it's appeared. Lovely. Okay, so we've got if y equals e to the x, then dy dx is also equal to e to the x. And let's use that to differentiate this function. Y equals e to the power of 2x minus 1. A much nicer, simpler example. So let u equal the inner function, 2x minus 1. That means that du dx is equal to 2. And of course, we have that y equals e to the power of u. So therefore, dy du is equal to e to the power of u. After doing this enough times, you'll probably start to notice some shortcuts, but it's okay. We'll carry on. Dy by dx is equal to dy du multiplied by du dx. And I always recommend writing out the rule, guys, every single time. So dy du is e to the power of u, and that's multiplied by du dx, which is equal to 2. So tidying that up, we have 2e to the u. That's just much nicer, right? It's nicer to look at. And 2e to the power of, or u is equal to 2x minus 1. Okay, there we go, guys. Alrighty. I'll show you another video where we look at some more exponential functions and maybe some slightly extended versions. But that is the main essence of differentiating an exponential function. Take care, guys. Just to remind you as well, video, subscribe, you'll be supporting the channel and you'll be supporting yourself.